Good morning. Can you hear me? Okay, fine. Thanks. Further to what the discussion we had today, the 3 sessions we have today, is little more. This I think is going a little more specific, I would say, but still, nonetheless, it will basically will cover all the concepts of the big data process that you are looking at actually. Okay, to start with, I think what I would say is I will introduce. Any of you know are you shareholders, or did any of you attend any shareholder meetings? Anybody? Or anybody transacts with shares, or any other company, or any holders out here? Yes or no? Okay, fine. So basically, I think I want to basically start with a very simple imaginary scenario actually. Like you are a investor and you are a shareholder of some company, and then you are basically looking at every year you get the annual to attend the annual meetings, right? So essentially you got a virtual, nowadays you're going to what we call virtual meetings. We're holding virtual shareholder meetings. In this context, what I would want to see is give an example to you is like suddenly some company X wants to start a shareholder meeting, and then virtual shareholder meeting is declared, and right at the time of thing, because it's virtual, right, everything is held on the web or whatever it is, whatever sources it is. In this context, what would somebody do is suddenly somebody realizes that some people working against the company or whatever it is, they've got their own complaints or investor activation, what we call investor activism, right? Somebody would want to disrupt your investor shareholder meeting, and this particular thing is called in the social media like Twitter or any other social media look like. Essentially, what you could do is basically you get what I would call an opportunity by which you could analyze this Twitter data or whatever it is and come back and say how to prevent the hackers to disrupting your shareholder meeting. This is basically a very simple example. In this context, what I want to say is how big data we have used, the data that is being flowed to get actually what is done, or to essentially to make sure that the work is business as usual. So to start with, actually Broadridge is we basically work in the three different areas actually. If you look at it, investor communications, what we call, and securities processing, and the third area that we look at mutual fund investment, mutual fund intelligence. In all these 3 areas, we do something what we call essentially every year we basically send around 2 billion shareholder communications to the shareholders. In addition, we do process almost millions of shareholder transactions every day. All this basically results in what we would call, how we, being a hosted service, we do what we do efficient, effective, and secure management of data. And how this having this large source of data basically helps us in what helps us to analyze, to bring insights, and what you can do, and how these 3 things can affect. Actually, we can say that it gives us the transparency, and we can understand the shareholder behavior, how people. We can understand the shareholder mindset, and we can mitigate risk, and then we can drive deep insights into what the behavior is and how we can react, or whatever it is. We can basically proactively use intelligence to market our service as well. So I would structure this basically discussion in 3 different areas. Since all of you are a little bit, I would guess we believe also about how a typical simple trade cycle looks like, and in what areas we can go ahead and apply this big data solutions, where all we can apply on. So essentially, if you look at any trade cycle, as I would say, it's very simple way. It starts with basically a pre and post decision, buy and sell, and a settlement and trade process, and what we call, while you are a holder, somebody is a holder of the service, we call asset servicing. In each of these areas, how we could use this. So before a decision is made, typically anybody what would do, you would get the recommendations from advisors, or you would get from market research or social media. So essentially, all these 3 areas you could apply in the context of pre and post trade decision. Once somebody made a decision, then what we call a physical transaction takes place, right? That's when you got the concept of settlement or investor behavior, where you could basically say that derive the results from the investor behavior. And the next step is, if you do while your physical process happens, in the next step in the settlement area, you could do what we call operational analytics, and settlement failure forecasting comes into here. And the last step is, while somebody is a holder of these assets, you can do sentiment analysis, voting analytics, all these areas can come in. So in what areas all these things we apply in? As I discussed, we could use in risk, we could use in compliance, operational efficiency, and scalability. And how we normally do this process is by, if you look at it, to start with, I think as we discussed before any analysis of data, you got basically 3-4 steps, right? What we call data preparation. Data preparation is a huge area because multiply you got a lot of data coming from multiple sources, multiple formats, and which all needs to put together. This you could basically put it what we call MPP, so massively parallel processing you can do. You need to do blending and processing, use a normal ETL tools like Informatica or any other open source ones available. Next step what you could do is essentially use this data to what? Predictive prescriptive analytics, in memory or on the fly text analytics, and finally essentially do all this to drive insights or actionable decisions, and finally what we call storytelling. Now having come to this basic process I explained, right? In this context we can go ahead and use 3 different cases I would just want to do, and being a huge processing, having a huge processing capabilities, right? One problem that typically we have is what we call portfolio performance computing. In portfolio performance computing, essentially is like we have got millions of transactions, that security processing that comes in, this data comes in over the night, and then we have got a short window cycles by which we need to put this data together and then keep it ready for the portfolio reporting to happen. And a typical scenario for us looks like you got like one of the applications that we got is 9 million accounts. On an average basis, we got 1 million activities are there on the system. And then why essentially in addition to that, you got a different set of customers where institutional clients having less number of activities but less number of customers, huge number of activities. This basically throws a different challenge out. Like being a processing problem, we don't have a context of daily. We process around 3 million data is there. Every day we get 2 million account activities basically flow into the system. And whenever any activity happens, to calculate the performance, we need to go back and see previous transactions and match up and do some kind of processing that happens. This basically cannot be done with a single batch job or something like that. So current system that we have got, because the different list of data distribution, with conflicting data distribution choices, like for example, like what I talked about, with huge number of data for small customers versus large number of customers having less number of transactions. This basically is a parallel processing problem where we could not go and solve an existing relation system. Like it was taking, our batch jobs were taking almost 16 hours per day on average. In some cases, we ended situations where we had 44 hours. Essentially, what it means is if you do a 44-hour processing in a window of 8 hours, essentially you end up doing 2 days processing. System is not available for you for the next couple of days. So there's no way the system was performing, and that's when we moved into what we moved into a green plum rack. That allows us to do parallel processing and help it at the same time. We could come back to from 15 hours under 5 hours. We could go ahead and run the processing. This is a very big success in that way, is because without this, there is no way we could go and meet our SLAs. And at the same time, in addition to this, we have got what we call on the real-time requirements. When somebody puts a report, since it's pre-computed data, everything must be coming in at the same time. Was able to respond around 50 to 100 requests in a minute time span. So we had just the SLAs were basically 2 seconds. We had to basically process and use the data out. This is one problem that we successfully implemented and have that. And this is purely a computation problem that has been solved by massively distributing the computation across multiple processes. And another problem in the mutual fund industry that I talked about is in the mutual fund data analytics, we have a situation where what we call MITS. MITS is a data store which stores essentially if you got there in North American market, you got almost 700 fund families are there which serve around 7,000 25,000 QSIPs, distinct, what we call distinct funds. Out of these distinct funds, on average, the market intelligence basically stores 2 billion transactions per year. And that comes down to something like every day we have to store around 10 billion, almost 30 million transactions come in every day weekly basis. The challenge here was because of the number of transactions were opening and we couldn't do horizontal scaling Oracle. What happened was again the same old problem, 7 hours batch size were taking around 7 hours, more than 7 hours at 10 hours we were taking it, and that resulted in the batch not being available at all. So next day morning when the business was ready for solve, there is no way we could service the request. This particular problem was solved again by moving to Greenplum, where we could load this huge data that was coming in terms of 30 million transactions, around 10 gigabytes of data was being updated in a matter of 6 to 7 seconds, 6 to 7 minutes I would say. That resulted in for us the system being available at a much shorter times. This basically enabled us much more to do. Essentially the old system wasn't even giving us a chance to meet the basic job requirements itself. This helped us to move in a different direction where we could go into a lot of analysis, come across, do some more drive a lot of insights, and then move forward from the just being a reporting engine to driving a lot of analytics out of the system out there. So again, the summary is essentially we could go from being a simple processing system, a reporting system, to multiple analytics, and we could go ahead and do a lot of analytics beyond simple reporting. And the last case I would want to talk about is big data and test analytics. This is something that I started the session with saying the scenario, right? Essentially every company is mandated to run the quarterly calls, and this data is available publicly. So what we tried to do is essentially analyze the quarterly conference calls of around 28 companies over a 7-year period. That basically helped us to identify what are the insights that we could driving into this data. Essentially, what are the questions that you could have? What are the popular themes of questions that analysts are asking, and then who asked, and what are the focus areas of the questions, and how the themes across change over a period of time. We could basically drive insights into it. Why I brought this basically more in the context of how we could go ahead and do a text processing, link it up with with visualization, and come with a drive very good insights. And what we come up with, essentially the word cloud basically showed us what are the different popular themes that came across over the time, how this changed over the time, and one more thing true isn't which analyst asked what questions, and how these questions change over time, and this particular visualization helped us to give us the bands of how these questions got changed. So product-based strategies, essentially what we could commence with how during the 7-year period what we observed was the questions that were being asked were products to change from the questions were not products. And in addition to that, for technology-based companies, what we found is cloud and creative cloud were on the rise over a period of time. And how this can be used? This basically allows us to do comparative studies, investor relations, and then anticipate and answer questions. And the last one more similar scenario that we could really think of is essentially when we want to do analysis of this huge data that we are talking about, right? For example, the settlement risk that we talked in the earlier briefly mentioned about, where we were looking at what is the risk? For example, risk means is what? Risk is in terms, settlement risk is what? You suddenly send somebody sell something or buy something. What happens is your onus is to either deliver the security or take the money out there to provide the money, right? So essentially we were trying to solve a problem for which predicting how the settlement, for example, if somebody makes a transaction, what is the risk of actually not meeting the obligation in terms of providing security or the money. We did an analysis of this and then came back and said, like, for example, we did almost analyzed our period of 1 month period, took all the transactions that come through and came back and specified around 100 different variables came out. And then when the insights, what the insights that helped us drive is helped us what? The insights helped us to understand that there are some reasons why you could predict what could fail. But the question the business is asking is, how, if you could predict how it is failing, can you predict what the reasons why it is failed? This is a bigger challenge because with 100 parameters out there, we could come with thousands of, probably we ended up with 10,000 rules. Now how do we map these 10,000 rules to something meaningful that business can understand? That is where the, I think aggregation of big data helps us to identify, link business with data and then insights. Thanks a lot, and then I think any questions, please?
I'm sure there should at least be one question. Yeah. I think you're audible, yes.
Yeah. Right.
But when we develop within a system, we see that plus minus 1-2% data, we are okay with this. Okay, so we can just let it go. But how do you take care of handling junk data in your system, which might be coming from different sources? But it is very important in the financial domain. You don't want to miss out on it because it may be having more value, not to move the data. How do you handle that?
Means essentially what you are saying is the ETL process needs to be clear for that, right?
Yeah, so you're capturing understanding of data and generating insight.
Right.
So how do you solve the problem that the data is not lost, because it is not understandable? How do you make sure that so some say 1% data is not identified? So how do you do it? Is it a manual process? You go to the data and try to make sense out of it, or how do you do that?
Means essentially ETL process must at least show you the outliers, right, to start with, and that is where you analyze the cleansing. If you don't do a proper cleansing operation, there is no way you could go ahead and do the further processing, right? So basically it must have caught at that. Assume it has caught that and somebody could understand what they implemented. Either you discard that or you discard that rule, right? So see, like I told you a simple example, like for example I told you, right, this one case I talked about where we were trying to prediction, right? I take 100 columns of data. Essentially what is it? What you are trying to do? Simple example. You got a value and see your decision tree has given you what? This condition plus this condition, this particular rule is failing. This particular rule is happening, right? In that context now, how do you interpret that rule in a business terms now? For example, say that, one simple example I can see, the failure can happen because of what? Because mismatch of the price. There could be a price mismatch. Or it could be somebody has actually the difference data for that particular data is not available. But these are data problems, right? What talked about. So there is these inferences you can just give up. But the other context, if you come across, when you know what the actual rule is, if you understand it, that makes sense. Then coming across these rules is very challenging. If you look at it, if you have got 1,000 data points, with 1,000 data points, with 1,000 100 different columns, assume that your rule is 4, right? You end up with what? 100 C4, 100 C4 combinations, right? So not all rules can be valid. So you need to delete what you need to do. Okay?